Okay, I've skipped a bit ahead because I don't think talking about traversal makes much sense until we've at least studied adding. We looked at removing, we didn't implement it yet, and we've also studied does it exist. But there's actually another idea, and you were talking about an ordering or traversal. So there's different ways to actually traverse a binary tree. And this is going to actually, I think this makes more sense when you look at the code, but we're going to try and think of it conceptually first. You have in order, pre-order, and can anyone take a guess on the third word?
Post order.
Whoa, nice.
Got it. Plus 5.
Plus-
Gotta get those pluses. Going for a C.
Going-
Gotta pass the class.
No, that's not happening. All right, traverse. All right, so in order, you go down the left tree, and then once you're done going down the left as much as you can, you print the value, and then try and go down the right, and then you continue on up. All right, pre-order, you visit the node, aka print the node first, then go down the left as much as you can, then go down the right, and you're done. This doesn't make much sense looking at the code. I mean, looking at these 3 steps. You have traverse the left tree, traverse the right tree, visit the node. All right, what's the only difference between these 3?
Where do you visit the node?
Yeah, visit the node. And I'm going to call visiting the node printing the node for now, just to make it clear. So the only difference between these 3 is the position at which you print the node. Yeah, in order, sequence, pre-order, and post-order. All right, let's look at the picture first. I think this will make some sense. In order, sequence, D, F, B, A, C, G, E. Wow. How did that come up?
Oh, okay.
Yeah. Well, if you remember the in order, first we're starting at A. We go all the way left as far as we can. We can't go left anymore. We print the node that we can't go left anymore. Then we go right, and now we're at the right. We're going to go left. Can't do that. Print the node, go right, can't do it. Pop, pop. We're coming up from D, so we're going to print B because we just came from the left side. Try and go to the right, can't do it. Jump up from B, go up to A, print A because we just came from the left side. Go right to C. At C, we're going to try going left. We can't go left. We come back, print C. Then we're going to go to right, which is E. Try to go left, which we can't. Go to G, try and go left, can't do it. Come back, print G, because we're coming from the left. Go to the right, can't do it. Come back up. Come back from G. Since we're coming from the left, we're going to print E, then try and go to the right, can't do it, and then we're going to go all the way back up the tree. Everyone got that perfectly, right?
Yeah.
First try.
Yes.
Yeah.
Plus 5.
Plus. All right. Any questions? Damon, was that a little hard to?
Oh no. I'm on it.
Okay. All right. Can anyone guess of how we did pre-order? We're going to still follow the tree the same way. We're still going to visit the nodes in A, B, D, F, back up, C, E, G, and then back up. But it's printing in a different way. So why is A printed first?
Because A is where you started.
A is where we started. Pre-order, once you get to a node, you print it. You do it. So you got to A, print it. Go left, we're at B, print it. Go left, we're at D, print it. Can we go left again? No. Go back up to D. We already printed it, so we don't need to do it. Go right, we're at F. First thing we do, print it. Try and go left. Yeah! Print it. Try and go left and right, can't do it. Pop all the way back up. Because we do try and go to B and go right, but we can't. So we go up to A. We go right to C. What's the first thing we do?
Print it.
Print it. Go left, can't do it. Then we go right to C. We're at E. What's the first thing we do? Print it. Then we go left to E. We're at G. What's the first thing we do?
Print it.
Oh man, we're doing great. All right, we go left to right, can't do anything. Pop up to E, go right, can't do it, and pop all the way back up. All right. So, in order, we printed in the middle. Pre-order was the first thing we do. Post-order, the last thing we do is print it. All right. So we start at A, go to B, go to D. We go triangle left, can't do it. Go back up to D. We're not done with D, so we don't print it. We go to F. We go left of F, can't do anything. We go right of F, can't do anything. We're done with F, so the last thing we do is print it. We go back up to D. Can't do anything more with D, so we print. All right. We go up to B. We check the right first, but we can't do anything, so we come back in.
Print.
So we go up to A. Can we do anything?
Yes.
Yes. So we're not going to print it. Going to go to C. try and go left. Obviously can't go left, back up to C. We're not done with C, so we continue on to E, go left of E, go to G, go left of G, can't do it, go right of G, can't do it. So we're done with G and we print it. If we go back up to E, we can still go right. So we're going to try and go right, but we can't. So we go back up to E and then we
Print.
we go up to C, we're done with C.
Print.
And then we back up to A, we're done with A.
Print.
All right. Hopefully this is like beating the dead horse by now. But are you anyone confused? Makes some sense?
So, like, basically, what it's doing is kind of checking. First, it goes down and kind of checks to the left, and then basically it's checking one side. Once one side is completely checked, then it tries to go to the other. Basically, it's like once you check both sides of each node, then that's when you kind of print.
Yeah.
Okay.
Yeah. All right. The coding for this is really, really simple if you use recursion. So we're going to go back here, and we'll do, which of the three do you want to do first? Actually, I'm going to leave that one, and then you can do the other ones as on your labs. Because hopefully, and I'll tell you how to do them, because it's really
Well, once you do one, we just kind of shift the order around, don't we?
Yes.
Okay. Because I mean, if it's all the same thing.
All right, so which one do you want to do first?
What was the first one we did?
In order, and we got in order, pre-order, and post-order. Oh, it's me.
We can do it in order.
You want to do in order? Why is it called in order?
Because you print it literally from least to greatest.
Yes. In order is going to print it from least to greatest. Whoops. All right, in order traversal. And since we're going to have a recursive function call, we're going to have in order traversal, and I'm going to actually, you're just passing it a node. Binary tree node node. So we're going to have both of these functions. Put them at the end. Oh, this is great. Okay. So the function call for in order traversal, we're simply going to call the in order traversal starting at the root.
It's Monday. It's fine.
Monday, I was up late, whatever.
It's fine.
Playing your Switch.
Playing my Switch. That was fun. All right, let's see if this actually makes some sense. Nope. Declared in class. Did I not type something correctly?
I hate those errors. I'm like, I typed it correctly. It's like, I don't know what you're talking about.
That's exactly how it talks, right?
Yeah.
I don't know what you're talking about.
Every time the compiler gives me an error, that's how it talks to me. It's like, you didn't do this.
You didn't do this one right.
Oh, yes, I did.
It's right there. Maybe I didn't save it. All right, let me try it again. Nope, it doesn't
Yeah,
like
and it
it.
was some stupid. Like,
Member function declared in binary tree. Oh, binary tree node. Hold on. Oh, yeah, because for some reason I decided to make this part of binary tree node and not binary tree. Again, it must be Monday. All right.
Yeah, I saw that. There we go.
But you didn't want to say anything? You wanted to just see how long it would take me to figure it out? Yeah, I see how it is. Uh-huh. All right, we're just going to... binary tree. All right, give me some values to add. Or, what did I call it? Insert? I already forgot. We called it insert. All right. We got 6, 18, 9001, 4, 73, 42. I think I heard a 72. All right. And then we'll just do bt dot in order traversal. All right, let's see. Make. Oh no!
BT.
Declaring the scope, probably because we should include the header file. Oh, right. And let's go ahead and run the test. Okay, good, it doesn't do anything. That's because we haven't told it to you yet. All right, so it calls in order traversal, which is going to call it on the root node. So this is I'm telling you, recursive is the best way to do it. What's the first thing you do in a recursive function?
You make your if statement.
Your if statement for the
Your base.
base case. First, take care of the base case. I'm putting this in all caps because every time a student doesn't do it, sadness occurs extremely quickly. All right, what's the base case here? You only have one thing. So if the node is
No.
null, get out. All right. So if we want to go down the left subtree, what can we do? We're not doing it iteratively, we're going to do it recursively. So how can we do it by calling our function? So let me go ahead and type this out in comments. 1, well actually 2.
You can say like node left or whatever.
Yeah. Go down left subtree. 3, print the node. And 4, go down right subtree. I'm putting it back. So 1, check if node is null, then return. All right. So how do we go down the left subtree? It's one call. Using our function, what are we going to do?
No previous. Wait a minute. I can't see that.
We don't need a rover. We're doing it recursively, right?
Oh, okay.
We're doing it recursively, so we will have in order traversal, and what are we calling it on?
The M left.
The M left, right? So node M left. So that's just going to go down left. Notice we have the base case, so once it hits null, we're done. It gets out. Oh, one line. Ah, that was pretty. It's amazing. Okay, let's go ahead and print it out. Oh, it's going to get nicer. Node mval. We'll go ahead and put in a little space for us. We need to include IO stream, so let's do that. Okay. And then how do we go down the right subtree?
We do the in order traversal on the right.
Oh, man. Are we done?
Yes.
Yeah. Wow, wasn't that easier than Rover?
I know.
Don't you have to
Three
see
lines
out?
of code.
Don't you have to see out the valve too?
Did I just do that?
Oh no, yeah, you did. Come on,
Man,
not live.
it's okay. The code was so small you didn't believe it.
Yeah.
Well, let me space it out so I can make it a little bigger. There. Now it's even spacier.
Yeah. I'm so used to having.
I've done like 172.
All right. So we ordered it from largest to smallest, which is fine. And hey, look at that. It printed it out. Okay. All right, guys. Part of your lab is implementing pre-order and post-order. What's going to change?
The order. It's good.
Plus 5.
Yeah, +5.
+5. Right. So the cout will either be before the in left or before the in order call on M left or after the in order traversal on M right. You have to see how this is a lot simpler.
Yes.
A lot of solutions in your binary tree, especially for the one that I'm going to talk to you about called a least common ancestor, is not difficult as long as you set up the recursion correctly. Okay. Any questions on traversal?
So you said the other ways of doing it where you switch the C out, is that just going to change which way it's ordered? Or
Yeah.
which way output's ordered?
Yeah.
Like whether it's least to greatest instead of greatest to least or something like that?
No, it's not going to do that. That is what's kind of complicated. Because if you look at this, the pre-order is printing the nodes first, so it's going to tell you what's on the root, and then what's left of the root, if there is one, otherwise it'd go right. So pre-order is printing it first, It's not necessarily printing it in any specific order.
Okay, so
I do have a question I'd ask. How come in that one, like, because I know you said it was fine, but how come in this one it's printing it from least to greatest, but we printed it from greatest to least?
Because of the order we imposed on our binary tree.
Oh, okay.
So if we go back up to here, if our mval is less than, we change the ordering here as well as down here. Basically, we reverse the ordering and then we run it. Now it'll be from least to greatest.
Oh.
Because that's how we inserted it.
Okay.
And I'm going to leave it this way. Great question.
Okay.
So hopefully everyone who's online will do this part. Otherwise, oh well.
They're very confused.
And you know, let's go ahead and clean this up just a little. Probably right after that in order traversal, we should do a \n so it all is on a new line. All right, there we go. Now it's nicer. Hey, look at that. Okay. Any other questions? Comments?
It depends.
It depends? All right. Actually, before I continue on, I just recalled that the lab does not ask you to print it out. The lab asks you to return a standard string representing the order. So I'm going to show you how you do that
Okay.
because it may be a little confusing. So instead of what?
Nothing.
Your face was great. What just happened? All right, so we're just going to change it from returning void to string. We're going to go over to our CPP, and then let's go do the same thing. And then we'll want to pretty much just return in order traversal, the recursive call, and then over here, string. So if it's null, we're returning the empty string because there's nothing in it, right? If it's an empty binary tree, it's an empty string. So instead of printing the node, we're just going to have, we should probably have a string var for ret. We'll have it start off as nothing. We'll have ret plus equals. We'll have, what was it? Node mval, and then we'll add a space. There we go. And then go down the right. Let's go ahead and return a ret at the end. A little more complicated. Actually, we can clean up this line of code a little by doing this. And that way we're just building the string as we're going down, as opposed to printing it out. Why am I doing this? Well, it's hard. I didn't want to try and test your output. I was going to try and test your function call. The reason for that is in case you have debugging information that you want to print out, I'm not going to count points against you for that. So we're going to just print out, get a standard string. That doesn't mean we need to update our main, because now we need to actually output it. All right. And let's see if we coded that all up correctly. Not yet. Probably because we need to include IO stream inside of our main.
That's another thing.
What, having to include everything? Ooh,
I don't know what CI is.
ooh, I wonder what our sig fault is. Wonder if it's what's using the,
Did you change the HPP file, the header file,
mm-hmm.
to be a string?
Well, it means that something in here is returning a seg fault. Ooh, well, let's go and do a GDB. Let's run it. Info stack. Oh, that's not good. Stringlen. Binary tree line 88. All right, hold on, guys. I forget that I do this very quickly. Source binary tree cpp.88. That's the top one that's in our code. Everything else is just confusing. Oh, it's this thing. Node mval. But if it's null, apparently I have forgotten how to use strings in C++. So let's go see if Google will help me.
It's the great big book of everything.
What's that?
The STL library is the great big book of everything.
It's a great big book of everything.
Well, look here, just got a going on with the new one. My sister just asked it home questions all the time.
See, modifiers, append to a string, which is really all we want to do. So I guess maybe we need to call append instead. All right, let's see if that fixes it. Whoops, let's get out of here. I did not like that. What does append take? Does it take 2 operators? Oh, pushback is what we're... Really? Append character? No. Append. Yeah, what's the problem? That's not an error. Error, no matching function call for int. Oh, it wants... Val. All right, let's see if there's an easy way to coerce this. If not, we're gonna have to use Google. No, it's not gonna coerce it nicely. So we need to C++ STL integer to string, converting it. Oh, good old Stack Overflow to the rescue. Good old Stack Overflow.
Not Stack Overflow.
Yeah, Stack Overflow.
Stack Overflow.
Oh, here we go. Oh, we call toString. All right, Stack Overflow to the rescue. Is that the voice? Whenever you're
Yeah, that's the voice you gave.
What you're doing is wrong, and you do it my way.
You're the only big thing we use here, so take your risk.
Oh my goodness.
My
Basic.
professor's asking for it going this way.
Oh, hold on. It's called toString, right? To underscore string. Oh my goodness. Get over yourself.
Are you serious? I just want you to know that would have, if I even figured that out, that would have taken at least 4 hours.
By the way, it didn't work because you're only printed 6.
And then I would have been crushed, and I would have thrown the computer.
All right. We're not there yet. It's a good start, but we're missing something. Why is it only putting 6? Well, it's because we're not actually appending everything from our in-order traversal and the 2 in-order traversals. So, ret.append from this guy, and then we'll do, wow, or ret.append from this guy over here. Because we need to actually get everything that's from the left, get everything from the right as well. Everyone okay with that? Sure. Hey, look, it worked that time. All right. Hopefully I've helped you out a little about how to debug the error novel that STL gives you.
A novel?
I call it the error novel. Like with STL, with the standard template library breaks, well, I mean,
Yeah,
can you read this in like 5 seconds?
No.
No. So I'm calling it a novel.
It's called the source.
The source.
So I can't say
But
the
when I
source.
did some research in templates, this is nothing. It would literally go on for pages, and then at the bottom it would say, "All right, too many errors, bailing out." This is literally what the compiler said. Yes.
You messed up so bad, I don't even know what you're doing.
Well, I mean, it would say that, and then I would change 1 line of code. Okay, it compiles.
Yeah. If it's a big, I've noticed that. If it's like a big error that it gives you, like it's probably like a semicolon.
Yes. Whoa!
It's like, oh well.
So make sure you compile and compile often and test. All right, any questions on what we did so far? Hopefully you can see that the recursive definition is actually pretty straightforward. Oh yeah, any questions, comments? Screens? All right, let's go ahead and stop. Wait, where'd our recording go? Oh yes, covered by Stack Overflow.